Welcome everyone to day 4 of Are You Ready for AP Calculus? In this series so far, we have covered so many topics that you might want to review over this summer before heading into AP Calculus. So here's everything you need to know. Day 4, make sure you subscribe if you want more of this type of content. Leave it a like if you're enjoying this, or if you've been enjoying this series so far, and comment. I read every single one. Let's get right into it. Our first topic today is areas and volumes. What is the perimeter of this shape? So now this area of this box or square, it could really be anything. Could either be 5 by 5 centimeters. It could technically also be 25 centimeters by 1 centimeter. It could be a lot of other things as well. But for integer values, for whole number values, these are our two options. So the perimeter of this shape could either be 5 times 4, which is 20 centimeters, or it could be 25 plus 1 times 2, which is 52 centimeters. There we have. It could also technically be like 0.5 centimeters by 50 centimeters, and that would give us 102 centimeters of perimeter as well. It could really be anything here. It depends on how you view it, and I left it open-ended like this on purpose. All right. A right triangle has a 13 centimeter hypotenuse and a one leg of 5 centimeters. So a right triangle, if we drew one out really quickly here, 13 centimeter hypotenuse and 5 centimeters for one leg. Find its area. Well, this is clearly a 5, 12, 13 right triangle. Know your special right triangles. And we solve the area by doing 1/2 base times height. 12 times 5 is 60, divided by 2 will be 30. Don't forget, this is an area, so it's two-dimensional space. We got centimeters squared as our units of measure. Number 3, the area of this trapezoid is 20 meters squared. Now, the area of a trapezoid is given by the two bases added together, x plus 6, times the height, and all divided by 2. That is equal to 20. Let's solve for x. 4 divided by 2 is just 2, and 2 times 10 is 20. So x plus 6 has to equal 10. X is simply 4, not centimeters this time, but meters. Whenever you're given units of measure in a problem, make sure you have it in your answer as well. Number 4, if the area of the square is 64, that means each side needs to be 8. We're given that it's a square, and this time that's how we know all the sides need to be equal. Find the area of the circle. Well, if we have 8 and 8, we know that the diagonal of a square will create a 45, 45, 90 right triangle, two of them. So the hypotenuse here is 8 radical 2, meaning that the diameter of this circle is now 8 radical 2. The radius of the circle, therefore, will be half of that, 4 radical 2. And the area of a circle is pi r squared. When we square the 4, that becomes 16. Square the square root of 2, that becomes a 2. So we get 32 pi as the area of this circle. Number 5, the diagram shows a part of a human aorta. That's the main artery that carries blood away from your heart to the rest of your body. Calculate the volume of this piece of aorta. Now, for the aorta, the blood needs to pass through this empty little cylinder here. So in order to get the volume of just this piece of aorta, I don't know what to call the stuff that creates the aorta. It's definitely not skin, but to create the aorta, we need this volume. We need this little shape. Well, then I need to take the outer cylinder, the volume of the outer cylinder, and subtract the volume of the inner cylinder. Okay, let's think about that for a second. So the volume of the outer cylinder minus the volume of the inner cylinder. So for the outer cylinder, a cylinder will be pi r squared h minus pi r squared h, but these are going to be different r's. One r is going to be bigger than the other, so I'll make this one big R. We will be using this in calculus as well, so this is very good preparation. Big R. What is big R here? Well, we're given that the diameter of the larger cylinder is 12. The base of the larger cylinder is 12 millimeters. So the radius will be 6 millimeters. The height remains 40 and pi minus pi. We have 40 as the height. And what's our smaller radius then? we're given that this right here is 2 millimeters. Therefore, this other side right here will also be 2 millimeters. That's 4 total that we're subtracting from 12 to get 8, and half of 8 will be 4. Another way we could have done this is we know that the radius of the outer cylinder is 6, the base of the outer cylinder is 6, subtract 2 from it to get 4. Same idea. We can simplify this expression by factoring out a 40 pi from both terms. So now we just have 36, which is 6 squared, and 4 squared, which is 16. So we get 20 times 40, which is 800 pi. Since we're talking about volume here, that's going to be millimeters cubed. Quite neat. Number 6, a solid is made from a hemisphere, so that's the hemisphere up here, and a cylinder with the same radius. This is our R radius. The ratio of the radius of the cylinder to the height of the cylinder is 1 to 4. So the radius is 1 to 4 the height. So we have 4r here. We are looking for the height of the solid. So we're looking for what 4r is. Keep that in mind. We're looking for h, not just what r is. Once you find r, you still have to find what 4r is. Given that the solid has volume 126 pi centimeters cubed, we know that the height will then be in centimeters. Keep that in mind. Work out the height of the solid. Okay. What is the volume of this hemisphere? Well, the volume of a sphere is 4/3 pi r cubed. But then we take half of that. So technically we just have 2/3 pi r cubed plus. What would the volume of this cylinder be? Well, the volume of the cylinder will be pi r squared times 4r. And we're told that all this will equal 126 pi. This kind of works out really nicely because we have 2/3 pi r cubed plus 4 pi r cubed. So 4 plus 2/3 is essentially what we are doing here. 4 plus 2/3. Well, 4 can be rewritten as 12 over 3. So technically we just have 14 over 3 pi r cubed is equal to 126 pi. Well, guess what? The pi's cancel. We're going to multiply both sides by the reciprocal of 14 over 3. That gives us a 3 over 14. It's kind of nice. Kind of looks like pi, but it isn't. So these cancel out because when you multiply a fraction or any number by its reciprocal, it turns it into 1. That is the definition of a reciprocal. And for those of you that have never heard that term before, reciprocal, look up that term, is equal to 126 divided by 14, just happens to be 9, which is a really nice number. 9 times 3 is 27. So r will be 3. Don't forget, it is in centimeters. And also don't forget, we're not done. We need to work out the height of the solid, which is 4r. The height of the solid will be 4 times that. So that'll be 12 centimeters. Ooh, we actually need to go a little further, don't we? Did anyone catch what the actual answer would be here? The height of the cylinder is 12 centimeters, but the height of the solid? There's another r here. So we have to actually add 3 centimeters to this, and our final answer will be 15 centimeters. That is a very neat problem, and if you got that, you're definitely ready to see areas and volumes in AP Calculus. Topic 2, composition of functions. This can get quite, not difficult, but challenging for some students that don't yet understand what a function is. A function is, for every input, we will have some output. So whatever x is, we're inputting that into wherever we see an x within that function. So h of f of x means we are plugging in radical x plus 2 into this x in h of x. So we'll have 5 times. This is f of x squared plus 1. So we'll get 5 times x plus 2 plus 1. And that gives us 5x plus 10 plus 1, which is 5x plus 11. Same idea here. We'll have 3 times h of x, because g of x is 3 times x. Keeping it simple so far. And now we have f of g of h of x. We already have what g of h of x is, right? If you look here, g of h of x is this. So I'm going to plug it in into f of x, all that right there. So we'll have the square root of 15x squared plus 3, and then plus that 2, That'll give me the square root of 15x squared plus 5. Beautiful. Now, f of g of f of x. All right, we're getting a little crazy now. G of f of x will be 3 times the square root of x plus 2. And we're going to plug that in back into f of x. So now we'll have all this plus 2. We have g of x. Okay, let's take this one step at a time. G of x is 3x. So g of x will be 3 times 3x. Well, g of x will be 3 times all that. And then g of x will be 3 times all that. So if 1, 2, 3, 4 3's. So 3 to the 4th, that's 81. So if 81x. Parallel and perpendicular slopes. This is probably one of the very first things you will see, maybe most likely in your first week in AP Calculus. So let's cover it right now so you have a head start. Find the line that passes through this point and is parallel to this line. What does parallel mean? Whenever you see the word parallel, you want to think same slope. Parallel lines have the same slope, which is why they never meet unless they are the same exact line. So in order to get the slope, I need to put this into slope-intercept form. So we have 2y is equal to negative x plus 3, just simple inverse operations. We're only worried about this negative 1/2. So we know that the slope is negative 1/2. And this line passes through this new point 1, 2. This is where we write point slope form. Point slope form. That's y minus y sub 1 equals m times x minus x sub 1. If you notice and divide both sides by this, you'll get back to the slope formula, rise over run. So keep that in mind. There's that connection. Y minus 2 will then equal negative 1/2 times x minus 1. We can distribute this out, simplify, and we'll get something like 1/2 plus 2, which will be 5/2. Beautiful. Find a line through the point negative 2, 2 that is perpendicular. So again, we have to solve for y first. We get negative 2x minus 4. And the slope here is negative 2. In order to get the slope that is perpendicular, we take the negative reciprocal. So negative of negative 2 is positive 2 and flip it. So that becomes 1/2. There's my new slope. Using point slope form, I'll get y minus y sub 1, which is 2. Our new slope of 1/2, and x minus x sub 1, which is negative 2. Let's go ahead and distribute, simplify. We get 1/2 x plus 1 plus 2, which is plus 3. Our last one here, trigonometric equations part 1. In day 5 of 5, or final day, next lesson, we'll be covering trigonometric equations part 2, and then we'll be getting into some limits graphically and algebraically as well. I hope you're ready for that. Let's go ahead and solve these out first. Let's change the color to blue just for fun. Solve for the unknown on the interval 0 to 2 pi. Cosine squared of 2 pi, or 2 theta, is equal to 1/4. The first thing I'm going to do here is get rid of this squared. So I'm going to take the square root of both sides, but keep in mind, whenever we take the square root of both sides of an equality, you must make sure you consider both the positive and negative solutions. So cosine of 2 theta is now equal to either 1/2 or negative 1/2. And where does that occur? Back to your unit circle that we've been talking about in days 1, 2, and 3. You need to know your unit circle measures cold. You have to know it. So cosine gives us 1/2 at pi over 3, 2 pi over 3, or 1/2 or negative 1/2. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. In order to get theta, we will be dividing all of these by 2. Or in other words, multiplying by the reciprocal of 2, which means multiplying each of these by 1/2 to get an over 6. And you can simplify where needed. Let's solve this one. We want to factor out a cosine of x. So we have cosine of x minus 1, and either of these could equal 0. So cosine of x will equal 0, or cosine of x will equal 1. Once we set this equal to 0, bring the 1 to the other side. Now, where does this occur? The cosine is equal to 0 at pi over 2 and at 3 pi over 2. Cosine of x is equal to 1 at 0 and 2 pi. And we don't have to go further because we were given this interval 0 to 2 pi, inclusive of both bounds. Let's solve this one. This one looks a little simpler. Use inverse operations to add 1 to both sides and divide by 2. I'm going to rewrite this 3 because I preach good handwriting and I want to preach it to myself here as well. Cosine is equal to 1/2. So where does the x value give us 1/2 on the unit circle? Those values are pi over 3 and at 5 pi over 3. We're going to divide both sides by 3, or in other words, multiply by the reciprocal of 3, which is 1/3. We'll get pi over 9 and 5 pi over 9. Let's go over these now. Sine of x plus cosine of x is equal to 0. This one's a little tougher because we can't factor. But instead, we're going to move this cosine to the other side. Meaning, now we're looking for where the sine of x is equal to a negative cosine of x. Where would that possibly occur? Where does the y value equal the negative version of the x value? Think about it for a second, and you may quickly realize that those values are 3 pi over 4 and 7 pi over 4. Because at 3 pi over 4, what do we have? We have negative radical 2 over 2, comma, radical 2 over 2. Notice how negative x value equals the sine value. Same idea for 7 pi over 4, except these will be flipped. Very neat problem here. All right. Let's check out this one. We do not have a 0 on the other side, so we want to bring that 2 over. Becomes a minus 2, and now we factor. Sine of theta minus 2 times sine of theta plus 1 is equal to 0. So either of these factors can equal 0. So this will equal negative 1, and this right here, sine of theta will equal 2. But does this ever occur? No. The sine of theta and cosine of theta, if you look at our unit circle, the largest values they can become is 1, right? Because the radius of the unit circle is 1. That's the furthest out we can go. Highest we can go is 1. Lowest we can go is negative 1. So a little more knowledge there to know. Sine of theta is equal to negative 1, exactly 1 point. And that's at 3 pi over 2. Let's try this one. Cosine of y plus 1 is equal to sine of y. Let's think about where that happens. Well, if cosine of y is 0, then sine of y needs to be 1. Where does that occur? That occurs exactly at pi over 2. Well, there's another case where if cosine of y is negative 1, then sine of y will be 0. Where does that occur? Well, that occurs at pi. Is there any other number that will work for this that we know on the unit circle? Let's think. Well, cosine of y cannot be 1 because then 1 plus 1 will equal 2 and sine of y will never equal 2. Let me know down in the comments if you can think of any others without using a calculator. Again, follow for more. Subscribe if you want more like this. Check out my other videos as well, days 1 through 3. We have 1 day left in our series of Are You Ready for AP Calculus? Leave it a like if you think it deserved it. And again, comment down below. I read every single one. I'm looking forward to what you have to say, and I'll see you in the next one.